Welcome to my channel. You are highly welcome. Good day to you from any part of the world. You are privileged to be seeing this video at this moment. My name is Femi. I want to walk you through practical geography, and the aspect of the practical geography we are looking at is a basic map reading and interpretation. My name is Femi once again, and today we want to be looking at map reading, map reduction, and map enlargement. So far, we've been able to look at basic essentials of a map. We've been able to look at distance, direction, and bearing. We've been able to look at scales of a map. We've been able to look at scale conversion. We've been able to look at measurement of distance. We've been able to look at measurement of area of a map. So far, we've been able to look at all of those things. And today we want to look at map reduction and enlargement. And I will be teaching from this book that I wrote many years ago. It is titled Compendium Practical Geography, a simplified approach to map reading and interpretation. One beautiful thing about this book is that it has practical workbook in it. So you are not just going to learn by reading, you are going to have a hands-on practical, because it has space that you can use to engage yourself, so that as you read, you understand, you can even put something down to demonstrate what you have learned. It's a very good book that will do you really good if you can lay your hand on a copy of this. And you can reach out to me on practical geography lectures at gmail.com and make your order. Then I will be glad to send a copy down to you from any part of the world. You make your request. Thank you very much. So let's go straight into today's teaching without wasting much of our time. Map reduction and enlargement. What are you going to learn? What are you going to benefit from this class? So at the end of this video, you are expected, I believe, that you will be able to mention the formula for map reduction and enlargement. You will be able to state two reasons for map reduction and enlargement, and you will be able to carry out basic operations on reduction and enlargement. Basic operation on reduction and enlargement. So, introduction. Okay, let's look at, before we do the introduction, what are the reasons for enlarging our map? What are the reasons for reducing our map? So to get a base map on which details may be added later by survey, and to get more space for adding and labeling further information. These are the two basic reasons why we carry out reduction, enlargement, whichever one we want to carry it out at a particular time and space. So let's look at introduction. Map reduction can simply be defined as the act of reducing the size of the original map. It is the act of increasing the scale of a map such that the map contains less information due to reduction in size. Now let me explain that the system, the act of carrying out, the act of reducing the size of a map in a way that the scale will become so big so that it contains very few information. That is what we call map reduction. The map enlargement, in the other hand, is simply defined as the act of enlarging or increasing the size of the original map. It involves reducing the scale of a map such that it can now contain more information due to increase in size. Now, let me give you a rule of thumb. A rule of thumb in this aspect is that the larger the map, the larger the scale, the smaller the map. And on the other way around, the smaller the scale of a map, the larger the map will be. So when you want to enlarge your map, be ready to have a very small scale. Very small scale. And if you want to reduce your map, be getting ready to have a very big scale. Alright. So to know if you are to reduce or enlarge a map, use the formula that I'm going to give you. If you are not told in the exam whether you are to enlarge or you are to reduce a map, and they give you a new scale which you are to work with, what you are going to do is that the new scale they give you, use this formula and say old scale over new scale. The old scale is the scale that is in the map you are provided with. The new scale is the scale that the examiner is asking, the examiner gives you in the question. So the formula is old scale over new scale. If you get a fraction, if the answer you get using old scale over new scale, if the answer you get is a fraction, then it means you have to reduce the map. If the answer you get is a whole number, it means that you have to enlarge the map. Let's go and see something. If the scale of a map provided is 1 to 50,000, this is the first scenario, first case. If the scale of a map provided is 1 to 50,000, and you are asked to produce the map to a scale of 1 to 100,000, for example, then the formula will be equal to old scale over new scale. So the formula becomes 50,000, which is the old scale you have on the map, divided by the new scale that you are given to work with. And what is the implication of this answer? If you do like this, you get half. Is that not so? So what is the implication? The implication is that you have to reduce the map. That is the implication. If the scale of a map, for instance, is this, like we get 1 over 2, this result simply means that the old map is to be reduced by half of its original size. The half of the map is what you will reproduce in your booklet as a student, as a candidate. In the booklet you are given, the new map you are going to draw there will be the half of the original size. So note that you must know that whenever the answer obtained is a fraction, it indicates that you are to reduce the map. But if the answer obtained is a whole number, it indicates that you have to enlarge the map. This is very, very important. So we have a second case. Like I said, they give you a new scale. The initial scale is 1 to 50,000. The new scale they give you is just 1 to 50,000. The first scale that is on the map is 1 to 150,000. The new scale you are given is 1 to 50,000. Just say old scale over new scale. And you have 150,000 over 50,000. That will give you 3. That is a whole number. And the implication of that is you are to enlarge the map into 3 times of its original size. That is the implication. Alright, so let's go to map reduction. Suppose a student or a candidate is required to produce a map with a given scale. How will the student or candidate go about it? So you have all of this procedure, and then I'm just going to go into practical with you so that you can just save the stress of going through all of this. I have explained it the other time, but let me go through it. Let me go through it again. Example: study the map extract of Ayila district to the scale of 1 to 100,000 in the figure below, and produce another map to a scale of 1 to 200,000. I want you to follow this. The scale of the map of Ayila district is 1 to 100,000. So you are required to produce another map to a scale of 1 to 200,000. Old scale over new scale. 100,000 over 200,000. That will give you 1 over 2. And I think that is the answer. What do you think? 1 over 2? 100,000 divided by 200,000 will give you 1 over 2. So, and they said, on your new map, identify and insert the following. So you have to impute the following into the new map you draw. Full length of River Baragada, full length of River Odan, and then Ayila town and Iwada village. These are the things you have to impute in the new map you draw. Alright. So this is the Ayila district map. Where is River Baragada here? Okay. This is River Baragada here. Where is Ayila and Iwada? This is River. This is Ayila. This is Iwada, and this is River Oda. Great. That's great. So, how do you go about this? Very simple. As you can see, the first thing you do is to measure the length. And let me tell you, when you are measuring the length of your map, don't measure the border with it. Please, very, very important. Take note of this important information. Don't measure the border with it. The border is not the map. The map is, it starts from here and end here. Don't measure the border and the key and everything. No, you will be wrong. So, you measure the length from here to here. You measure the breadth from here to here. You put it down. You use the scale to convert it to kilometer. Alright? I mean, sorry. You don't need to convert to kilometer. Please, I beg your pardon. So, you just measure whatever you get. You put it down. Then you remember that the scale is 100,000. So, if you divide the old scale by the new scale, what you are going to get is 1 over 2. And what it means is that you have to multiply the length you get by 1 over 2. The breadth you get, you multiply it by 1 over 2. The answer you get is your final answer that you are going to use to measure the new map you have to draw. Alright, so the new length, the old length is 10 centimeters. So the new length will be 10 centimeters times 1 over 2. How did I get 1 over 2? I use this formula. Okay? I get 1 over 2. So you use this scale that you converted, you use it to divide the old length, and I give you 5 centimeters. So the old width, which is this one, the old width from here to here is 9 centimeters. So the new width will be 9 centimeters times 1 over 2. If you do this, you have converted it using the scale. Alright, so the new scale is 1 to 200,000. So what do you do afterward? You draw. So you draw your 5 centimeter, you draw your 4.5 centimeter, and then you now divide the original map you are given. You divide it into this line, this vertical and horizontal line. They are called grid lines or grid references. But better you call them grid lines. Alright? Okay, so when you divide it like this, what you will get, permit me to go back to, so you divide the old map like this. It will help you to be able to know where to insert all the features you are asked to insert in the new map. That is the essence of dividing the whole old map, the original map. That is the whole essence of dividing it into grid lines like this. So that by the time you draw your new map, you will be able to know where to impute what you are asked to impute. Now look at Ayila map now. Ayila village or city or town, as it may be, is started from the second grid bus. If you count it from left to right, it's from the second grid. If you count it from the bottom to up, bottom upward, you see that from south northward, you will discover that Ayila village starts from the second grid to third grid in a southeastern direction. So look at what we do here. The same thing here in this over. This is the second, what do you call it now? This is the second grid, either from the southern part towards the northern, or from the western part towards the eastern part. You discover that this is how it's located. Then you look at River Baragada. You can see that River Baragada started from the northwest here and run through to the southeastern part. It started from the second grid and ends on the fourth grid here. The same way it was here. It started from the second grid and ends on the fourth grid. And this is what you find in this case. Alright? So this is how to impute features on the new map that you produce. We are going to see in the next class. Alright. So now, note that when a new scale is not given, it is with the steps below. We are going to look at this in the next video. And I hope you have learned something in today's class. I hope you have gained something, really. I will be very happy to see you in my next video. Till then, please, if you have any worry, any concern at all, anything that is not clear in what I've said so far, put it in the comment section. I'll be very glad to reach out to you again. Till I come your way, I wish you success in your class activities. I wish you success in your future exams. Thank you very much for being part of this class. Peace out.